So this is the fundamental theorem of algebra, and I always think that we should use it more than we talk about it, but we use it, we just don't always say, hey, let's use the fundamental theorem of algebra. All right, and it says this: if you have a function and its degree n, so that's important, the degree is n, and n is greater than 0, so it's not the constant function, okay? Then f of x has at least one complex 0. So when we say complex 0, the 0 could be an integer, could be a rational 0, could be irrational, could be an imaginary number. Okay, so it just has to have at least one 0, okay? So then what we're saying is, if I have a 0, let's say the 0 is c sub 1, then I know f of x is equal to, and I can take a factor of x minus c sub 1, right? And then I have like this other polynomial in here. You know, after I did the division, then I'd have this quotient over here. There's no remainder because it was 0, right? Okay. Well, then this polynomial, the degree is n minus 1, right? Okay, so then I can say, use the same principle to do another factor, another 0, right? There's got to be a 0, okay? And so then I have x minus c sub 1 times x minus c sub 2. So we say, okay, let's say this one has a 0 of c sub 2. All right, so then there's a factor of x minus c sub 2. And then I have another polynomial that's left over. And so maybe it's, you know, some polynomial in here. But then that's going to have a factor as long as n is greater than 0, you know, as long as the degree is greater than 0, then I can keep going. So what happens is I get this. I get that my function can be written as a group of linear factors, x minus c sub 1, x minus c sub 2, and so on until I get to the end, x minus c sub n. There will be n linear factors, okay? So that's really important because now we know if we have a degree 3, then our polynomial is going to have 3 zeros, okay? If we have degree 5, it's going to have 5 zeros. We have to consider multiplicity. So if a factor is in there 2 or 3 times, then you have to consider that as part of counting up the zeros, okay? All right, the other thing we have to consider is there could be a constant that was common in all of the factors, like it was a greatest common factor that got pulled out at the very beginning. Now we've done some work with this idea in another section, so we'll see that again as we do some examples, okay? But that's the idea of the fundamental theorem of algebra, that you're going to have, you know, say you have a 5th degree polynomial, you're going to have 5 zeros, and then you can write them as linear factors and get the polynomial. Okay, so we'll see an example or two.